Good morning. This particular house here, this customer has called us out because they were having concerns with mold and fungus and a lot of moisture down inside their crawl space. So they reach out to us and we're saying, hey, we know we've got a problem, but we don't know what that problem is or really where to kind of get started on not only diagnosing the problem, but certainly solving the problem. So today I want to just walk you through with me as we do our first part of our process here at Heartstrong, which is just taking you through an inspection to show you how we kind of thoroughly go through and the things that we're trying to identify to give you a better understanding of what it is we're going to look at. So in turn, we can educate you on what those things are and help you to be able to make an informed decision. So why don't we go ahead and head on back to the crawl space and get into the good stuff.
Okay, so when we're evaluating a crawl space, there are 4 moisture threats that we're looking for very specifically during our inspection. It's going to be plumbing leaks. It's going to be moisture coming from the soil. We find that by exposed earth where there's no vapor barrier inside the crawl space. The third is bulk water intrusion, which is signs after periods of heavy rain. And the fourth is going to be air exchange. On this particular house, we took time to look around at the plumbing. We're able to properly evaluate the supply lines of plumbing because it's under pressure. We did not see anything leaking. But to be clear, one of the most common forms of leaks actually comes on a plumbing discharge line. It's not under pressure during the evaluation, but it's very easy to show up when we get done with our process because you'll see at the end this is a very clean environment and helps to be able to establish and identify that. We talk about the second moisture threat. I want to talk about the moisture that actually comes from the dirt, from the earth inside the crawl space. You'll see inside of here that there is a vapor barrier. That's what this black stuff is that's on top of the actual soil itself. The purpose of it is laid down to cover up the dirt. And the reason to cover up the dirt that's down here is because it's to try to trap the moisture. And there's actually water vapor that comes off of the dirt up into the crawl space and contributes to the actual humidity and the moisture inside of the air. So one of the things we're looking at is not just, is there a vapor barrier? Is the vapor barrier, is it good? Is it in good working condition? We also pay attention to what its thickness is because we want to pay attention to things like what's its permeability rating, how much moisture and soil gas goes through that particular liner. And then most importantly, are there any gaps in the liner? Is it missing in areas? Is there exposed soil? Because that again is going to allow that water vapor to come up and go where? It's going to come up and get inside of the wood and eventually contribute even to the moisture inside the home. That third moisture threat is going to be bulk water intrusion. That means after periods of heavy rain, water is going to enter in through the cinder block, through hydrostatic pressure, or the groundwater table rising. We pointed out in a previous little clip, but if you pan for a second and look this way, you can clearly see the amount of mud and silt staining on top of the plastic. That's going in the direction of the lowest point of the house, so you can clearly see all this mud is from the water that's being carried during periods of heavy rain, and that's got to be dealt with. Now, the fourth moisture threat is what we call air exchange. And to spend just a minute on air exchange, what this is that these crawl spaces here in the Tennessee Valley have what's called the foundation vent. Those are those openings you see when you walk around your house, and maybe if you're old enough, you remember people used to say, hey, those are the things I need to close during the winter and open during the summer. Well, those allow direct air to come into the crawl space. That might be fine if it wasn't for the fact that in the summertime, the air outside is very hot and it's also very wet. We also measure that moisture by something called dew point temperature outside. Well, that hot, wet air comes into the crawl space, and the crawl space this time of the year is much colder than that outside air. So what happens when hot air from outside comes inside of the crawl space? Well, it causes actually the crawl space to get wet, and we can see that with the amount of water that's standing on top of the plastic here, because it's causing this ductwork to actually sweat and rain all this condensation because it's the coldest surface down here. Now, part of our evaluation, we can clearly visibly see that, but we also want to evaluate is we know that when that air comes inside, the leading indicator is going to be that the humidity is going to go up inside of the crawl space first. Now, what I've done in preparation just for this particular video is I've set a sensor, a remote sensor up outside the house. It's going to be tracking the temperature and humidity outside today, and I have a device inside the crawl space to tell me what the temperature and humidity is inside the crawl space, and I'm going to use this to teach you the science that I'm talking about. This top where it says outdoor, the temperature outside today at the sensor is 90 degrees Fahrenheit. The humidity is the second number. It's 58% relative humidity outside at my sensor. The bottom two numbers where it says indoor, that's at this sensor right now inside the crawl space. This particular homeowner's crawl space, as you notice, is 73 degrees Fahrenheit. But let's pay attention. What's the relative humidity inside here? 96%. That doesn't seem to make sense. How could it be 90 degrees outside with 58% humidity, but 73 degrees Fahrenheit with 96% humidity? This explains the science. Folks, understand that that hot air at 58% humidity comes inside this crawl space, and because the air is cooling, it has less capacity to carry moisture. Therefore, the relative humidity goes up dramatically inside this space. So much so that it not only causes the ductwork to sweat, the next thing that starts to happen is the insulation gets wet, which is why it's failing and falling all around me inside of this crawl space. And then the other big thing, it might be difficult, let me cut my light on, might help. The other thing that happens, once the relative humidity goes up for a period of time, the wood moisture content goes up. We're concerned with that because that's what causes mold and fungus to grow and the wood to actually decay and start to break down the structural integrity of the home. So what we're looking for, we want to see moisture contents that are below 12, 13, 14% in the wood. So what we're going to look at here right now, let's kind of take a look and see what the wood moisture content is inside here. We can clearly see it's over 20%. Matter of fact, it's getting close to, oops, sorry, let me light it back. It's getting close to 30% wood moisture content inside of the wood. And so what that's telling us and trying to help educate you as a homeowner, to make it real simple, outside air is hot. The air inside this crawl space is much colder. Hot air comes in, collides with that cold air. It actually causes the moisture and humidity to rise and go up. Think of when you take a can of Sundrop out of the fridge, set it on the table, it starts to what? Sweat. It's colder than the air around it. So the humidity goes up for a period of time and duration. Then what starts to chase it is the wood moisture content. And that's what leads to things like mold and fungus growth, starts to cause the wood to decay. It also can cause and accelerate massive deflection in the floor. Wood naturally has a deflection and bounce to it, but that gets much worse with the expansion and contraction from the wetting and drying, because in the wintertime, this will do right the opposite. The wood will actually dry back out and shrink back up. So what happens over years or decades, depending on the age of your home, is you have this expansion and contraction of the wood, which begins to show things inside the house, such as squeaky floors, uneven floors, doors that stick, windows that stick, things like that start to show up inside of the home. All right, the other thing we want to be sure to make sure that we're educating our customers is this is a pretty typical crawl space you're going to see during the summer months here in the Tennessee Valley. And the reason we say that, we're talking about the amount of sweating ductwork and condensation. We got water pooling from the ductwork down here. We got high signs of humidity, high signs of wood moisture content. Well, here in a few months, when the temperature falls and starts to lower outside, what's going to happen is this crawl space is actually going to dry out. So if I was in this very same crawl space, let's say around the holidays, for example, you're not going to have sweating ductwork. We'll see the signs of it because we'll see the water droplet pattern on the plastic and be explaining to you saying, hey, look, I know it's not raining down there right now because the fact that the actual science, because the air outside is colder than the temperature there inside the crawl space. So that means that the crawl space is staying dry and drying out. But we'll be able to see the signs and explain, hey, look, when you get into this time of the year, which is spring, summer, and even into the fall, this is what's going on inside of your crawl space. And we're just being clear because sometimes we come out and talk to people during the wintertime and say, hey, look, here's what goes on in your house. And they kind of look at us like, that's kind of hard to believe, right? Because it's not actually going on. And that's because, to be clear about the problems in this crawl space, it's seasonal. But it actually makes it worse. And the reason it makes it worse because it's seasonal, not year-round, is because you get an extreme wetting period where it gets so wet, the wood moisture content's 20, 30% down here. The fungus is growing, and the wood starts to expand and wants to acclimate to that environment, the wood of your framing system of your house. Well, then it gets dry outside, and now the wood framing system of your house wants to acclimate and shrink back up. So that movement back and forth is why I may be talking to you at your house right now in the middle of the wintertime, and we're talking about things like slopes and unevenness in your floor. Your floors are creaking and squeaking. Doors are sticking. Sheetrock's cracking above your house, and you're sitting there saying, man, is it really that wet down there in the summertime? That's why we're going ahead and shooting a video right now to explain this is what it looks like in the summertime, even if we're at your home doing an evaluation in the middle of the winter. All right, so the other thing that we want to pay special attention to here in particular is going to be evaluating the actual structural components of the home. And by structure, we're going to pay attention to how the house is framed as far as the wood and the framing system, but also how the foundation is set up on a house. Now, in this particular crawl space, because we're paying so much attention to the foundation, not just looking, for the things that might be happening around in the crawl space, we're also going to look up and say, what's going on how this house is built. There's a big component to that, which is going to be something like this pier right here. This is an actual pier that was built during construction. And one of the challenges during construction when you're actually building a house is they block a pier up like this to a point. But then what happened when they were actually building this, if we look up here, is it actually ran short of what the elevation needed to be. And this right here is actually a load wall. This is a double floor joist that has a load-bearing wall sitting on top of it. Well, in order to be able to get it properly supported, when they were building the house, they actually turned a 2x on its side, and they have a shim, but the shim's only on one of the two wall doubles, or the double joist, excuse me. And as a result, you can see that there's a settling that's happening on this particular board versus this board right here because of the framing miss is what we call it. In our report, we call it framing misses because we fill out a PDF report during our evaluation that we send to you with pictures and video explaining this. The other thing that should jump out to you, especially if you're in construction, is that there's no mortar inside of these block joints whatsoever. Now, not here to make any commentary on whoever built the home. It's just that because there's not mortar on this, it can also cause problems such as shifting and settling. It's naturally supposed to have the mortar inside of it, which is why I'm going to actually walk you right over here right now and show you what happens and what can happen to a pier when it's not properly installed. It's steering a weight. So it may not be easy to see on camera, but this particular pier right here, much like its brother over there, it doesn't have any mortar inside of the joints, okay? It's supposed to be blocked up here. I'm going to use my light a little bit to help. It's shimmed, but more importantly, this whole pier right here is slightly shifted over to the right. And it's shifted to the right because of the type of footer that it has. The footer did not come out very far. It only came out to about right here. And also because this thing was never mortared up. So the sheer weight that's sitting on top of this load here over time has caused this to have a slight shift off to the side. So we want to make note of that. Not that the house is going to fall in, not that the house is going to fail. That's not why. But this is an area I will explain to the homeowner and say, you want to pay attention and look for some signs over time that might show that the floor is getting soft or has a little more bounce to it, or maybe feels a little uneven, especially during certain times of the year. So that's a big part of evaluating what the structure looks like. Now, the other thing we pay attention to is actually what size lumber your house is framed with, what the on-center spacing is, which means how far apart they sit, and then how long those floor joists are, because all those things can contribute to things like, if you ever walked through a kitchen or a bedroom and heard something rattle off to the side, well, that's deflection. And deflection happens naturally in all framing lumber. But sometimes when a house is framed, that span is just too long. We call it overspanning. And it has too much deflection and too much bounce that it not only becomes aggravating because of the rattle, it can actually start to sag on span. Because going back to the summertime, like right now, the wood is expanding with all the moisture and holding on to it. In the winter, it's letting go. And oftentimes in the winter, we see other things show up, such as the end of what's the wettest season, floors inside of your house. Hardwood floors will start to cup. LVP, luxury vinyl planks, will start to have little bubbles in them inside of your house. And that's all because that high moisture that it's trapped. And you get deep into the wintertime when you start heating your house and start drying the wood back out, the wood starts to shrink back, and I call it the snap, crackle, pop season, where you're like, why is this kind of snapping, crackling, and popping inside of my house? And that's just because that extreme variances in both temperature and moisture content and humidity inside of your crawl space. So we're getting to the end of the evaluation down here. So let's kind of summarize what we've seen and what the next steps are going to have to be. So in this particular crawl space, it still has this old subfloor insulation. That's got to come out and it's got to be removed. The next step that's going to have to happen is the fungus that is on the wood is going to have to be treated and removed as well. There's an important step that'll happen with our company before we can even begin the work, which is we're going to actually come out to the home before we start the project. In other words, when a customer signs up with us, typically in about 24 to 48 hours, we send a technician out to do a temporary dry out. What that means is this environment is way too wet with the standing water, the sweating ductwork, and the wood moisture content on the wood. Whether you choose to do a soda blast to remove the fungus, or you do an actual cleaning with a hydrogen peroxide treatment, or whatever you choose, the wood moisture content is too high. It's too wet. You can't come down here and clean it and do it properly. So we have a technician come out and temporarily block up all the vents and direct air exchange and install a temporary dehumidifier so that we can lower the relative humidity and reduce the wood moisture content to prepare this particular environment to be properly treated for the fungus and also to stop the ductwork from sweating so that when we get to the final touches, we don't have water that's just raining and dripping all over top of the project. So we've identified insulation comes out, the fungus gets treated, a temporary drought prepares for that. The other things this home is going to have because of the amount of water that comes in after periods of heavy rain is we're going to install a complete drainage system inside the crawl space along the footer with a drain pipe that'll go to a sump pump, sump basin, and discharge all this water to the exterior of the home. And then we're going to get into doing the energy efficiency improvements down here, which with our company begins by installing a liner on the wall that's actually an insulated barrier that's going to not only block out the heat and cold from the house, but it's also going to insulate the inside of here and then fully encapsulate this space, install a dedicated dehumidifier, a new insulated door, and a few other touches that we'll get into. But that's what this particular house is going to need. And we're just really excited about not only presenting the solution to the customer, but excited about what this is going to look like when we get done, because we know we can be extremely successful on this particular project. As we start the first step of the repair process, we remove the old subfloor insulation. But this isn't a tear it down and make a mess process. Everything is handled carefully to avoid disturbing fungus and mold spores. Working section by section, the insulation is lowered in controlled pieces, rolled tightly, and sealed into heavy-duty bags inside the crawl space. Those sealed bags are then passed out, loaded, and hauled completely off-site, keeping contaminants away from your home and your air. With the crawl space cleared and prepped, we move into fungal remediation using a liquid treatment designed to kill active growth while cleaning the wood at the same time. Before application begins, we protect the home by controlling access, using containment where needed, and applying the product precisely so it stays where it belongs. The treatment is methodically applied to joists, beams, and subfloor surfaces, reaching the areas where fungus can hide and spread. As it works, the results are visible. Dark staining begins to lift, and the wood brightens back to its original yellow pine color. That change isn't cosmetic. It's a sign the surface is being cleaned and restored. Once coverage is complete, we inspect for missed areas, clean the workspace, and leave the crawl space safer and ready for long-term moisture control. To control water before it becomes a problem, we install a full interior perimeter drainage system. This begins with digging a trench along the footer around the entire inside perimeter of the crawl space. Precision is critical. The trench must be the correct depth, width, and pitch to move water effectively. A corrugated perforated drain pipe wrapped in a geotextile sock is laid into the trench. This allows water in while keeping silt out. The pipe is hand-packed into place, leaving the foundation wall edge slightly exposed. That detail allows the system to capture water entering through the wall, as well as groundwater rising through the soil. The line is pitched toward the sump basin, directing water to a controlled exit point. With the drainage system in place, we install the components that actively remove water from the crawl space. The sump basin is positioned at the lowest collection point where the perimeter drain feeds directly into it. Intake holes are properly sized to allow water in while keeping debris out. The basin is leveled, set to the correct height, and backfilled with clean gravel to promote fast water flow into the pit. Inside, we install the sump pump and connect the discharge with a check valve to prevent backflow when the pump shuts off. The discharge line is routed out of the crawl space and buried underground, terminating with a pop-up emitter away from the foundation. When the pump runs, water exits safely and stays sealed when it's off. With moisture managed, we move into energy efficiency and long-term protection by installing our insulated encapsulation wall liner, one of the most impactful crawl space upgrades. We use an exclusive zero-perm liner that creates a true thermal break at the foundation wall. It addresses all three modes of heat transfer, slowing down conduction through masonry, stopping air movement, and reflecting radiant energy to stabilize temperatures year-round. The liner is carefully measured and installed for a tight fit, with a small inspection gap left at the top to meet termite code requirements. It's mechanically fastened, then fully sealed at all edges and transitions to create a continuous system. The result is a sealed, insulated foundation wall that supports comfort, efficiency, and durability throughout the home. Next, we focus on the crawl space foundation piers. Each pier is prepped by removing excess mortar and rough spots to create a smooth finish. Proper prep ensures tighter wraps, cleaner seams, and a more professional finish. While wrapping piers isn't required for ceiling performance, it dramatically improves the overall appearance of the crawl space. Fully wrapped piers create a bright, uniform look that feels intentional and high-end, especially when viewed from the access opening. Each pier is cut, wrapped, and secured with clean, consistent seams, elevating the entire space visually. With walls and piers complete, we install the crawl space floor liner for full coverage and a clean finish. Precise measurements and planned cuts ensure the liner stays square and tight across the entire floor. Overlaps are consistent and intentional, enough for a reliable seal without excess bulk. Around piers and along foundation walls, tight, accurate cuts eliminate gaps and bunching. The goal is coverage with a smooth, professional appearance from wall to wall. This is where the system truly comes together. The floor liner is taped to the wall liner, creating a clean, continuous transition from foundation to ground. That seam is kept straight and level across the entire crawl space. Floor seams are then sealed using proven techniques that keep tape flat, fully bonded, and free of wrinkles or bubbles. The result is a system that seals exceptionally well and appears nearly seamless when viewed as a whole. It's a detail-driven step and one that reflects years of experience. To maintain long-term humidity control, we install a dedicated crawl space dehumidifier. The unit is elevated on cinder blocks, which are wrapped in white to blend seamlessly with the liner. Rather than relying on a condensation pump, we use gravity drainage tied directly into the crawl space drainage system. Water exits automatically without moving parts that can fail. Once installed, the system operates on its own. The humidistat controls cycling, and drainage happens passively. No manual involvement is required. We finish by building and installing a custom crawl space access door. The existing door and framing are removed so the opening can be rebuilt correctly using pressure-treated lumber, ensuring everything is level, square, and solid. A refined installation technique includes a deliberate spacer at the bottom plate. This allows exterior water, if ever present, to pass beneath the door frame and into the drainage system instead of pushing inside. The door and exterior trim are constructed from PVC composite, a lifetime material that won't rot or deteriorate. So the entry door to the crawl space is an area of massive air exchange because it's a wide open spot that's uninsulated, that air can pass in and out of the crawl space and cause those problems with relative humidity. So what we've done on this house is we built our custom sealed door, but we've also got a few nuanced pieces to the installation that really helps with the moisture and water control. One of the things that you'll notice is we've got the floor liner that comes up to the door, and it's actually pulled up underneath that bottom trim piece of the door because you can't see it. There's a gap underneath the frame of the door. So if water tries to hit the door and come in underneath that door, it falls underneath the plastic and gets diverted straight down and into that drain pipe and then properly carried to the sump pump and out. All right, so you've made it to the best part of the project, which is the end. I appreciate you bearing with us throughout this entire process. So I just want to take a moment and recap how we got here. When we first came out to this house, if you remember, we had subfloor insulation that was still in the crawl space. We had a lot of fungal growth on the wood down here. We had a problem with water intrusion after periods of heavy rain, and we saw that with all the mud and silt staining that was on top of the plastic. And of course, we had a very high humidity problem down here because of air exchange, as we talked about in the previous video. So I want to take a moment and just recap what we've done. So chronologically, what we started with is we completely removed all of the subfloor insulation. And so to put your mind at ease, it's not that your home is uninsulated, it's actually better insulated now. And what I mean by that is during our encapsulation process, what we've done is the barrier that we put on the foundation wall, that's an insulative barrier. So we've moved the insulative barrier from the subfloor of the house because this used to be unconditioned airspace. And we put that thermal barrier on the foundation wall, which according to the EPA is where we want it to be. And we've accomplished that with an actual R5 liner. And that liner is a great way to accomplish this because it has three modes of action. It works via radiation, it works via convection, and it works via conduction. There's actually a reflective backing to that liner that's facing the cinder block wall that's reflecting heat and cold off of itself. And then it's strategically built to have 2 air gaps inside the liner. So that's what accomplishes that full thermal break along the wall and really is going to help improve the energy efficiency of the home. And so we pulled the insulation out, we treated the fungus. Then to deal with the standing water problem, you saw in the video where we dug that trench all along the footer inside of this crawl space. We installed that drainage pipe, and then we pitched it down to a sump basin and sump pump that we've installed. That's what's now over here in this far corner across from me in the background, and we'll have some better footage of that in a minute, but you'll be able to see that now we've got all of that water is now being actively collected instead of passively collected like it was before, and it's being sent down to one location and then pumped and discharged underground and completely on the outside of the house, which is what's going to keep this space dry all the time, even during periods of heavy rain. And then the last piece was, of course, the air exchange, which was what we call an encapsulation. But what that started with was putting an R10 thermal barrier, insulating all the direct air exchange, which is the foundation openings. And then we also sealed up that big wide open gap that I showed you where the HVAC opening was for the supply and the return lines to come through. That's been properly insulated and sealed. I mentioned about the thermal barrier on the wall. And then we put, in this particular crawl space, we put down what's called our world's strongest vapor barrier because it's puncture resistant for this particular customer so that they can enjoy the benefits of it being a true zero perm liner, but also one that just can't be punctured either from something coming down on top or something from underneath, so that it'll keep it lasting for a very long time. And then the last 2 pieces here was we installed permanently the dehumidifier because we did do that temporary dry out, but that was, again, just temporary. We've got it permanently installed now. And then we built a custom insulated and sealed door that we'll be able to show in a video as well. So the last 2 things we wanted to talk about just to kind of prove the science, though, is if you remember in the previous video during the original inspection, we talked about what the temperature and more importantly, what the humidity was down inside the space. And I've got a device down here now so that we can kind of see exactly where that's at. And let me light it up here to see if that makes it a little bit more visible. So what this is now currently showing us in this environment, the relative humidity right here at this meter is about 58% relative humidity, and it's about 73 degrees Fahrenheit. So you can see that there's a dramatic change. So even though this is obviously a very beautiful looking space down here now, but the most important thing we were trying to control was that leading indicator, which was relative humidity. And you see that we've accomplished that. And the customer also has a device inside of their home. So now they don't have to come down here to track that. They can just track it from inside their home and have the peace of mind to know, hey, my system's working and it's functioning properly. And then, of course, we talked about that lagging indicator, which was the wood moisture content, which is what causes fungus to grow and causes the wood to start to degrade, and have problems. And so we're going to reread that wood moisture content here again, and let's see what it's sitting at. So we can now see that wood moisture content is hovering right around 14% inside the wood. And that's, we talked about in the previous video, we really want to be below 16%. And the good news is we're just about, sorry, let me push back pressure so you can see it, because if you take the pressure off, it goes down. But you see it's around 14%. And what's going to happen here is that's going to normalize over the next 3 to 6 months, so that instead of having that extreme wetting and drying to the crawl space, now that it's a completely conditioned and controlled airspace, it's going to normalize like the rest of the building envelope for you as a homeowner, which is going to give you the peace of mind for things like we talked about, stuff like sagging floors and expansion. And most importantly, the biggest thing is the indoor air quality too. Now that we're controlling that humidity, mold and fungus just simply can't grow and thrive in this environment. And it gives you the peace of mind to know, like, hey, this has now become an asset to my home versus something that's threatening my home. It's an asset because the energy efficiency, customers, the EPA tells us, can experience anywhere from 15 to 20% energy savings in real money. Number 2, we know the National Association of Realtors tells us that the home value can increase by as much as 10%. So if your home's worth $500,000 today, making a full repair plan such as this can increase that value by as much as $50,000. And also give you the peace of mind to know that, hey, I've got a return of my investment for the money I've spent. So we'll take a few last minute videos and footages to show you what this turned out to be, but we're super excited and really thankful for this customer to give us the opportunity to help them out. We look forward to serving you.